Okay, in this video we're going to talk about the cofunction identities. And so in order to do that, I'm just going to jump in with an example where I'm going to write down this triangle here, which is a 30, 60, 90 triangle. And we've talked before about the lengths. This is one way to write the lengths of a 30, 60, 90 triangle. You could multiply all of these by 4, and then you'd have everything twice as big. The proportions will stay the same when we're talking about how to find, say, sine of 60 degrees. Sine of 60 degrees is opposite over hypotenuse. So that will be square root of 3 over 2. But now let me find cosine 30 degrees. For cosine is always adjacent over hypotenuse. But what I see is that what's adjacent to 30 degrees was opposite of 60 degrees. And we get the same answer. And then also note that 30 degrees plus 60 degrees makes 90 degrees. If I have a right triangle, the remaining two angles have to have a sum of 90 degrees because all of the angles have to add up to 180 degrees. So what I'm going to do now is draw a more general triangle, still a right triangle, and the shape I've just sort of arbitrarily chosen here. If this is theta, these two non-right angles must have a sum of 90 degrees. So this guy becomes 90 degrees minus theta. Okay. And what I'm going to see then is that if I have, well, I'm going to just break down and maybe label this A, B, and C. So if I have cosine theta, this is going to be adjacent over hypotenuse. But if I look at, say, sine of 90 degrees minus theta, I'll get the same thing because adjacent to 90 minus theta is B. Sorry. Opposite of 90 minus theta is A. Adjacent to theta is A. That's why these are equal. And similarly, if I do sine of theta, opposite of theta is B, divided by the hypotenuse. But if I compare then to 90 minus theta, B is adjacent to 90 minus theta. So cosine of 90 minus theta is B over C. And you can look at tangent theta. Tangent theta will be opposite over adjacent, so it's B over A. But how is B related to 90 minus theta? That's adjacent. And so and then A is opposite, so adjacent over opposite is cotangent. So these are our cofunction identities, and you can just keep going on these. Like, for example, you can, I sort of don't want to do it that much, but anyway, if you have secant theta, why did I put the degrees here? I started doing that. I need it for 90, but not for the theta. Okay, secant theta is going to be, it's going to be hypotenuse over adjacent. It's, it's the reciprocal of cosine. But if that's going to be cosecant of 90 degrees minus theta. And then all of these can be rewritten in terms of, pi over 2. Let's just finish off with an example. Instead of writing 90 degrees, I can write pi over 2. That's what I meant to say there. Okay, if alpha, that's alpha, do a different letter, is equal to, actually, if alpha is an acute angle, so all this proof has to do with them being an acute angle. So an acute angle is between 0 and 90 degrees. Let's put like a little thought bubble there. Okay, if alpha is an acute angle such that sine of alpha is equal to 4/5, find cosine of 90 degrees minus alpha. So it's not really not much to it. Maybe I need a better example. Cosine of 90 degrees minus alpha is equal to sine alpha, so that's also equal to 4/5. So, yeah, that's not much there, really. I mean, this is actually really important. I'm just saying my example is not much. But this is actually what's more important. Just trying to somehow let it sink in there, but okay. So these are the cofunction identities.